Huh. All right, damn it. Okay. I don't see the first name as Iris very often. I always thought it was a pretty name.
Yeah, I have people tell me that a lot, but I've met so many people. It's great.
Yeah, when I was in high school. Come to find out, popular name, like a couple of years ahead of me was Linda was a very popular name for about 3 or 4 years before me. And one girl said, my parents thought it was such an exotic name, not realizing that everybody else in the world was naming their child from the female child. Morning.
Did you move classrooms?
Huh?
Did you move classrooms?
Are we supposed to be next door?
Yeah.
I do this every time, don't I? Every time. Joshua, can you hear me?
Yes, sir.
Well, you hear me, but I can't hear you. Wait, hang on a second. Oh, hello, everybody. I'm going to, I have to switch rooms. So I'm going to have to make someone the host while I leave and come back. So Ms. Garcia, that's you. You're going to be co-host for a while. Well, I do this every morning. I'm in the wrong room. You can't because I was muted. Can you hear me in there?
Yes.
In there. Okay, great. All right. So now I do this, 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 and this. Okay. I don't want it to show it like that. I don't like that. I'm gonna whine here in a minute. Okay. And well, I'm still trying to get things squared away. I don't like these particular display settings. I like display settings. And now this goes over here. Oops. Well, that wasn't supposed to happen. There we go. No. That wasn't what I wanted over here. Where is it? It didn't do it the way I wanted it to. Huh. Okay. There, I'll put it there. That was the mistake. Oops, that's not what I wanted to open. Oh, fucking hell. Excuse me. Damn thing's pissing me off. Download. Only it didn't download. PDF file. That's what it's supposed to download as a PDF file. Now I'm seeing what I'm seeing. Okay. PowerPoint. Well, it looks like I don't have any other choice other than using this damn thing. Anybody know how to close this window over here on the side? That's gonna piss me off. Okay. I need to do here. And this, share screen. Okay, so everybody on in Zoom. Where is it? Where is it over there? This is why I get here at 7:30 in the morning, so I could get all this set up, which I had done in the other room. Okay. So everybody in Zoom, make sure you have signed in to the chat. If you have not signed into chat, I have marked you absent, which I haven't uploaded to, which is one of the things I'm going to do today this afternoon is update all the attendance files in ACES and in Canvas. So please be aware of that. Oh, let me do this. So y'all get this screen here, but the problem is you're not going to see me write anything. I left my remote at home. I didn't realize I'd done that. So as a consequence, I'm going to have to use this stupid camera here for all of this. And that means y'all aren't going to see very well. Okay. So converting here. Oh, I'm just going to leave that alone. That's not going to be on the test. So, so it's converting degrees, minutes, and seconds. Well, 25 seconds is 60 minutes. And so you do that divide and you get a decimal number. And then you add the 47 in front, 47 point whatever, and that's going to be minutes. And that's out of 60 degrees. And then you do that divide, and then you do the 63 and the decimal. Okay. And so that's how you convert the angle to a decimal degrees. And then going the other way, the point 43 is the number of minutes. So you multiply by 60 and you get some number followed by a decimal. The number here is the number of minutes, and this is the number of seconds. So you divide that out, no, you multiply that decimal number. This decimal portion gets multiplied by 60. And that will give you the number of seconds. And then you round to the nearest second, so there won't be any decimals. Sometimes I'll ask you to round to the nearest, to the first decimal place, or something like that.
Excuse me, sir.
Yes.
We can't see nothing on the screen.
Yeah. But it's all on my on here on my video. So in the the only thing I can do to fix this, possibly help this may not be you the greatest solution. But I think a little flexible. Tell us the remote home for their cam.
Well, do y'all, let me put it this way. What questions do y'all have for me about the home, about the review, other than the conversion deal and the radians and sectors and that stuff? Is that, I'm not gonna.
That's everything for over here. Camera.
That's a lot better.
Yeah. It's not the greatest, but
Let me see. Put it this way.
okay. You still get the shared screen of the PDF file, right? And then my screen. You go ahead and pin my screen and whatever. Make it larger. So this converting stuff, like from 1 to 15, actually beyond that. Oh, man. There it is. Anyone see it over there? Yeah, there it is. The first 21 questions. They're important to know, but they're not imperative to, I don't think it's in the SLOs for this course, but they're things you need to know. So that's why I put it in the review and you have homeworks over it. Now, how numbers 21 through 29 will be done on the test is I don't know if I put it in the files. There should be, if there isn't, there should be a worksheet in there that looks something like, and all four quadrants are gonna look just like this one here. Where there's, on the outside, it's gonna have the coordinates of the key angles here, as well as the quadrantial angles. And this continues all the way around the circle. Okay. And then inside, there's a box and an oval. I don't know if if they're in this order or they're reversed, it doesn't matter. And on the test, you're to fill in this chart with the appropriate radians and degrees. And it's all the way around, even on these, I think. So you put in the radians and the degrees and the ordered pair on the unit circle. So you just fill in the unit circle. And I think that's how the question is, fill in the unit circle.
I have a question.
Yes.
Is there like a formula sheet or any tools that we're able to use during the test?
The basic trig identities comes closest to having a formula chart, but for this test, I will not provide one. Those I want you to know. So there really isn't a formula chart. This first part, these are things that you need to walk away from this course having in your head. Okay. So that's why if I think it's important enough that you need to walk away with it in your head, I won't give you a formula chart for it. Okay. So those like sine of theta is 1 over cosecant theta, and cosecant theta is 1 over sine theta. So these inverse relationships, those you should know. Cosine and secant are inverses, or reciprocals, I should say. Tangent and cotangent are reciprocals of each other. The trig identities, knowing that sine squared plus cosine squared equals 1, because that's based on the unit circle. Okay. And y'all can't see what I just wrote on the board because my camera's not pointed over there. So those are the formulas. And what is it? Sine squared plus cosine squared equals 1. That's just the Pythagorean theorem, because on the unit circle, the radius. So here you have a right triangle. This is cosine of theta. This is sine of theta, and this is 1. And this is a right angle. So our ordered pair here, cosine theta, sine theta, are x and y. So this is just the formula x squared plus y squared. Well, y squared plus x squared equals 1. Where 1 is so this is the formula for this is the equation for a circle, and with a radius of 1. And so that would be r squared. In this case, r is 1, y is sine theta, and x is cosine theta. So that's the situation we have there. Yeah. So knowing those fundamental identities, trig identities, you should know those. They should be in your head. Just like knowing the unit circle should be in your head. If you go further into mathematics and into engineering, that will be very helpful. Okay. Does anybody have any questions on specific problems?
All of them.
All of them. Well, I okay. So from what I'm reading in chat, can y'all see this on the share screen? Can y'all see this? This should be on your share screen.
No, it doesn't show. It only shows a black screen.
There it is.
Yeah, but what I want y'all to see is the PDF file, the whole thing. So all you're seeing is what's on my webcam right now, right?
Correct.
Okay, let me try again. Let's see.
Now
Hello?
we can see it.
Yeah, now I can see it.
Okay. Okay. And this is all you see on the shared screen, right?
Correct.
Correct.
All right, that's what I wanted. All right. And now I gotta. Oh, wait, it's doing it this way. Move this over there. All right. So now. Numbers. Only a half hour in the class. Okay. So. Oh. So g of theta is cosine theta. So if theta is 45 degrees, what is a cosine? Cosine of 45 degrees. By this point in time, you'd have already done this, and you know that 45 degrees was that ordered pair. Yeah, square root of 2 over 2. So I wrote a 3. Square root of 2 over 2. Well, what do you get when you square this?
1.
Nope. All right, so they want this squared. So I'm going to square the numerator and the denominator. If you just square the numerator, you get 2. If you just square the denominator, that's a 4. So that's 1/2. So please be aware when you're squaring a fraction, you're squaring both the numerator and denominator. All right, the next one What's sine of 45? What's true about the sine and cosine of 45 degrees?
They're the same.
They're the same. So we do 4 times that. So that's going to be 4 times the square root of 2 over 2, which is 2 square root of 2. Because the 2 and the 4 get reduced, the 4 goes to 2 and the 2 goes to 1. And so 2 square root of 2. So when they say do not use calculator, that means you're going to write it using a fraction. And possibly like the cosine of 45 square root of 2 over 2. That's the exact answer. That's not punching it into the calculator. And so what's cosine of 60? From the unit circle, what's the cosine of 60? And what's 60 degrees in radians? Yeah, pi over 3, 60 degrees is 5/3 radians. And so what's the cosine of 60? Square root of 3 over 2? Yeah. So the cosine of 60 is the square root of 3 over 2. What's the tangent of pi over 6? What angle, what degree angle is pi over 6? 30. That's this angle here. So for tangent of theta, what is that? What do we use? What's that ratio that tangent equals? There's 2 appropriate ratios, fractions here. What?
Y over X.
Y over X. What's the other one? Sine over cosine. Sine theta over cosine.
Earlier you said that the cosine of 60 was square root of 3 over 2. I thought it was 1/2.
Cosine of 60.
Cosine.
You're right, it is 1/2.
Mhm.
Yeah, those get me sometimes. So, yeah, this one's 1/2. And I was thinking that sine square root of 2 over 3. I mean over 2 and square root of 3 over 2 and then 1/2. And then square root of 2 over 2 and then the square root of 3 over 3. So yeah, it's 1/2. So here we have x is 1/2. So what's y? What's the sine of 30 degrees? Or pi over 6? No, the sine is the y value, which was the square root of 3 over 2. And then this is just 1/2 times the square root of 3 over 1/2. So those go away and it's just the square root of 3. Okay, find the exact values. All right, so this is using your trig identities. What you know about the unit circle and the trig identities. Cotangent of 45 is actually the same as the tangent of 45, because at 45, the sine and cosine are the same. So this is just 1 minus the sine of 45. One minus the sine of 45, and 45 at 45, both sine and cosine are the same number. And so to write this as a single fraction, because that's what we want, this is the same as saying 2 over 2. So I wrote a 3 again. I don't know why I'm doing that. Square root of 2 over 2. So Then we have 2 minus the square root of 2 in the numerator and 2 in the denominator. So it's 2 minus the square root of 2 halves. And that's how we work these. And the sine, well, the cosine, and tangent. So it's getting like denominators and then changing the numerators appropriately and combining them appropriately on these. So yeah, I don't have time to work through every problem here. I'll come back and do some more if need be. Okay, so now, let's see, how we have the page break? Yeah. So now I'm going to come back up to so 37 through 40 is just talking about where does the angle wind up? And then what is that angle? Okay, so 405 degrees. So that's more than 360, right? That's one complete revolution. And so I'm going to subtract here. That's going to be a 5 and that'll be a 4. So that'd be 45 degrees. So this angle actually looks like this, which is the same as just doing a 45-degree angle. And then whatever the sine of 45 degrees is, that's what the sine of 405 is. Same thing with cosecant of 960. Well, I start thinking the third multiple of 360 is 720. And so that's 3 times around the circle. And then I'm going to subtract that from 960. And 6 minus 2 is 4, and that's a 240 degrees. Well, 240, this is 180. $240 is over here, which is the same as, yeah, 240. Okay. So if I come up here, this angle here is 60 degrees. And so what were they asking for? Cosecant? Cosecant is the inverse of sine. Sine is negative down here, so whatever I get of cosecant of 60 is 1 over the sine of 60. But I need to change the sign because sine and cosecant are negative down here. Only tangent is positive here in cosecant. So the sine of 60 was square root of 3 over 2, right? So the reciprocal of the square root of 3 over 2 is 2 over the square root of 3, and then we multiply by the square root of 3 over the square root of 3, so we get a rational number in the denominator. And we have 2 square roots of 3 in the numerator. Yeah, this worksheet has all the answers. So the answer key is after everything. So that's how you do those 4. These 4 questions are based on y equals a sine omega x and y equals a cosine omega x. And the period t is 2 pi, I wrote 2x. I forgot, I have to do it over here because you can't see that on my webcam. And these are formulas you need to know. And the period for both of these is 2 pi over omega. So when they ask you for the amplitude, well, the amplitude is actually the absolute value of A is the amplitude. So on number 41, the amplitude is 2. On 42, it's 5. On 43, it's 1. On 44, it's a positive 3. Finding the period. Well, I divide by 1, that gives me, and I'm doing both on all of these. I'm dividing 2 pi by 1, I'm dividing 2 pi by 4, which gives me pi halves. Dividing by 5 gives me 2 pi over 5. Dividing by 1/4 is the same as multiplying by 4, so it gives me 8 pi. Okay, so that's how you do those. If you need me to work it out to show you how I got those numbers, please don't hesitate to tell me to do so. Now, graphing this, we need to know the amplitude. So that'll tell us how high and how low we're going to go. And we need to find the period. I'm going to write the see it. So in this case, what is the amplitude? 2. So that means the function is going to go to, the highest it's going to go is 2, and the lowest it's going to go is -2. What is omega for number 45? Omega is what x is being multiplied by. X is being multiplied by pi, so omega is pi. So 2 pi, the period t is 2 pi over omega. So in this case, it's 2 pi divided by pi, which is just 2. So I like to scope it out on the number line. So 1 to 2. 2 pi, I mean, pi is 3 point something, right? So 2 would be about here. So this is 2. You're not seeing me draw it on the screen, so this is 2 over here, where pi is over here somewhere. Okay, so we're closer to, so basically what it did was shrink it. We're doing a horizontal compression. And so halfway is 1, 1/4 of the way is 1/2, 3/4 of the way is 3/2. So our key points for sine are, the first one is 0, 0, so this one's going to stay 0, 0. The next one is the x value and the maximum, 2. The next key point is the x value and 0. The next key point is the quarter value x, the 3/4 value for X and -2 in this case, the minimum, and it comes back to 0. And then the next one, which would have been at 3, no, 2.5. 2.5 and then 3. So this is pi over here. So it comes back up to here and then comes back down to here. It's a little, I squunched it up a little bit. And then going to -1/2, it comes down to here. And then at -1, it comes back up to 0. And so this is what the graph is going to look like. Now, on the test, I will give you one of these things, but you won't have values for X on the X here. You decide what the tick marks are for you. Okay, so if it didn't have those tick marks on there, it didn't tell us what the X, Y, what the X values are, I would just automatically assign, I'd come out here, 1, 2. And so this would be 2 here, and this would be 1, so this would be 1/2, and that'd be 3/2. Okay. Questions on that one? If we were to do this using the T-points, our T-points are 0, 0, pi over 4, 1, pi halves 0, pi -1. What was the next one? 3 halves pi 0. Wait a second. Is that right? And then no, because at 2 pi, it's back to 0. So what am I missing? I did something wrong here. Oh, I know what I did wrong. I added an extra point. Pi over 2, it's at 1. And at pi, it's back to 0. And at 3/2 pi, it's at -1. Okay. And if I had my unit circle right in front of me, like you're supposed to have, because that's going to be one of the first few questions on the test, is filling out that chart, you'll have all those points on there. And so changing the X value is what we did here to get these numbers down here on the number line. So the 0, it stayed 0. And the half pi became 1/2. So basically, I'm just getting rid of the pi here, replacing it with the appropriate value. And now I'm going to multiply each of the Y values by the amplitude. Or by A, not the amplitude, by A. Because sometimes A is a negative number, so be careful there. So I'm multiplying 0 by 0 gives me 0, so 0, 0, stay 0, 0. 1/2 1 became 1/2. I multiply by 2, 1/2 2. 1 0 stayed at 1 0. 3/2 -1 became 3/2 -2, and then 2 0 remained 2 0. The x-intercepts remained the x-intercepts. What changed was our maximum and minimum values. They changed by a factor of A. So that's that's not doing anything. So cosine. Yeah, you can see me do it here. Again, the amplitude is the absolute value of A, and A is -4. So the amplitude is 4. The period, again, is 2 pi over omega, and omega in this case is pi again. So that's going to be 2 pi over pi, which is 2. So our period is 2, which is about here. No, that's 3. That's 3. So this is approximately 2. So halfway is 1. And this is going to be 1/2. And this is 3/2. But now we're dealing with with cosine and not sine. So our key numbers change up here. So instead of these y values, all right, cosine at 0 is 1. Cosine of pi halves is 0. Cosine of pi is -1. Cosine of 3/4 pi, 3/2 pi, again is back to 0. And then at 2 pi, it's up to 1 again. So that's going to be a 1, 0, -1, 0, 1. Now my new x values of these points will be the 0 will stay 0, but now the x value goes to 1/2, 1, 3/2, and 2, like I just had in the previous one. And my y values remain the same because I've changed the y values. Because now I need to multiply by A. A is a -4. Instead of going up to 1, now it goes down to -4. Because I multiplied by a negative number, it changed my maximums to minimums and my minimums to maximums. Excuse me. At 0, it's going to stay 0. At -1, it goes up to 4. At 0, it stays 0, and at 1, it goes down to -4. So here are our minimums. Here's our maximum. And so this is what it looks like. And the zeros are here. And so I would continue it on to 3/2 pi, to 3/2. No, not 3/2, so to 5/2. And down to, well, I'd go up to 3 and down to, so I come up to here. So the next one here is going to be at 0. And then it come up here to 4 again. And then at -1/2, it's at 0. And we're at +1, it's going to be up here at 4. So where cosine normally goes what that show, yeah. So cosine would normally go something like this. Now it's been squunched towards the y-axis and pulled y-axis and pulled away from the x-axis. You'll get one. Possibly where omega is a fraction. Just realize when you're dividing by a fraction, you're multiplying by its reciprocal. Okay. Now, on these next two graphs, number 49 and 50, deal with where does it cross the y-axis, and does that relate to sine or cosine? All right, this one, number 50, it's here at 5, so that's more a cosine. Whereas with sine goes through the point 0, 0, so this one fits with sine. The amplitude is what are you multiplying the maximum x value, y value by? Well, in number 50, the maximum y value is 1, and it jumped up to 5, so in this case, the amplitude is 5, and 5 times 1 is 5, so A equals 5. So right away, we have 5 cosine omega x. So now we just need to find out what omega is. So we use the formula T equals 2 pi over omega . Well, yeah. This is 3/2 pi. Right? Well, the first 0 is at pi halves. So pi halves is back here. What do I multiply pi halves by to get over there? I multiply by 3, right? 3 times pi halves equals pi over 3. So, I mean, 3 pi halves, sorry. So this means I multiply the angle theta you divide by omega. So that means 2 pi over omega equals 3 pi over 2. So I get pi halves equals 3/2 pi times omega, because I just multiply both sides by omega. And now I'm going to divide by 3 pi over 2, which is multiplying by 2 over 3 pi. So I'm going to do 2 over 3 pi times pi over 2, and that's what omega is. The 2's go to 1, and the pi goes to 1, so getting rid of my 1's, omega is 1/3. And so omega here is 1/3, so this is 5, y equals 5 cosine 1/3 x. Multiplying by a fraction, multiplying your argument by a fraction is a horizontal stretch. It's pulling things away from the y-axis, which is what it was happening there. Again, so, well. Ah. See, this might fool you into thinking that this is the period here is 2 pi. But this is only half of the period. Because with sine, you hit in a single period, you hit the x-axis 3 times. Here's the first time, the second time, the third time is going to be over here at 4 pi. So 2 pi over omega is going to equal 4 pi, which means omega is 1/2.
To make sure, what question are we in?
This is number 49 that I'm talking about. I just got through doing number 50 and 49. Oh, I did 49 over there, didn't I? So 49. It goes from 0 to 2 pi. The picture does, but it only crosses the x-axis only once in that interval, where with sine it should have hit the x-axis 3 times. Once at 0, once at the end, and once in the middle. So a period for sine would look like this, but it only goes to here, 2 pi, so that means this has to be 4 pi. So that means I multiplied 2 pi by 2, which is the same thing as 2 pi over omega. Right? Multiplying by 2 is the same as dividing by 1/2. So this is saying that it is 2 pi divided by 1/2. So that means omega is 1/2. Or if I just do the straight and then multiply both sides by omega and then divide through by 4 pi, you still get the 1/2. Have I mentioned before that I play with numbers? And understanding how fractions work helps you see this sort of stuff. So, because I can see this sort of stuff, because I understand fractions, I can play with it, and so I don't have to do much calculating to find out what omega is. So this is what, oh, and then the high value is supposed to be at 1, but it's at 3. So that's just multiplying by 3, so the amplitude is 3. Because this should have been at 1 down here, but it's up here at 3. So A is 3, and A is a positive 3. So it's going to be 3 sine 1/2 x. 3 sine 1/2 x. Okay. We got another 40 minutes. So yeah, that's all right. What I'm gonna do right now is look at my notes to make sure that what I have for the exam fits. Or even if I break the exam. I know this part of the exam is the unit circle. So I need to make sure. Which means I need. What do I need? Do I need one of those things? No, it's online. Okay. Never mind. Come back on. You got it turned off. Doesn't make any noise. Do you have any questions on any specific problems that I haven't covered so far? Because we have time. There we go. No, I haven't created the exam yet. So, yes, this covers what's going to be on the exam. Because I create this exam based on the review I created. And yeah, I kind of glossed over a little bit of the beginning here. About these things. You will probably see one or two of these on there. Or two or three, depending upon. But you will have a question on there. And it will say, fill in the unit circle. And so you draw a unit circle, or you have printed up that worksheet. See if I. Yeah, I do have it in there. There's a unit circle that is the one that I used in instruction, and then there's another, it's called blank unit circle. And yeah. So let me show that one very quickly. This share. This one. And it's not showing here. Is it showing there? In Zoom, are you seeing the unit circle? Yes or no, maybe so.
Yes, I'm seeing the unit circle.
Okay. And so, yeah, you would fill it in appropriately. Or this would be, well, it's your decision whether you're going to put radians in the square or radians in the oval. It doesn't matter. I can tell what you mean. And then this point here would be -1, 0. And then you just fill all this in appropriately. This is something you should be able to map. You should definitely have the first quadrant in your head. All right, where this is 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. And this is 0 radians, pi over 4, pi over 6, pi over 4, pi over 3, and pi over 2. And then you have 1, 0, square root of 3 over 2, 1/2, is that right? Yeah. Square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, 1/2, 3 square root of 3, square root of 3 over 2, and then this one's at 0, 1. And then everything down here in this quadrant is reciprocal across the origin or with respect to the origin. So this will have the same x and y, except the signs will be opposites. This will have the same x and y's, the signs will be opposite. Same thing here and here of the angle across. So you follow across. Okay, so where this one here is with this one, this is square root of 3 over 2, 1/2. This is going to be the negative square root of 3 over 2, negative 1/2, and then on down the line. Where this point down here is going to be just 0, negative 1. And then the angles, because it goes 0, 30, 60, 0, 30, 45, 60, 90, and then another 30, so that'd be 120, 135, 150, 180, and then on down around. And then the angles, the radians, you fill those in appropriately. Okay. How many questions will be on the exam? Between 15 and 25, closer to the 15 number at this stage of the game. Realizing one question is going to look like this. And this will take up to 15 minutes to complete. It should only take about 5 minutes to complete. So yeah, there's a lot of time involved because some of this stuff, although it's quite simple and easy, it takes a lot of time. It takes some time to write things down and to figure some things out. So knowing these really helps, especially when you're evaluating, finding the exact values of the trig functions. Understanding that you can go more than 360 degrees and still wind up on one of these angles. And I've been referring to the reference angles every now and again. Well, the reference angles are the angles in the first quadrant. 0 to 90 degrees or 0 to pi halves radians. Those are the reference angles, and all the other angles are built. I have the same cosine sine value and tangent value, but the sine is appropriate to the quadrant. So like this angle here, its reference angle is the 30 degrees over there. And I don't, did you see it on there? No. So if we have this angle here, The reference angle is this angle, which is this angle in the first quadrant. And if we're trying to find sine, sine's going to be the negative of this one. If we're trying to find the cosine is negative down here as well. If we're trying to find the tangent, well, the tangent is positive in the first and third quadrant, so it's positive here. Same thing happens here. So if we have this angle, or even going around to here. The reference angle, this measure going this way. This is the reference angle for this angle. Whether you're talking about going in the positive direction or the negative direction. And whether the X and Y up there, the X is going to still be positive, but now the Y is negative. Cosine is the only trig function that's positive down here. Well, cosine and secant. Well, I always talk about the three primary, but realize that their reciprocal functions have similar qualities. So. That's why I stress the first quadrant. So. Okay, any questions from here? All right, I will throw, well, all right, converting from radians to degrees and degrees to radians. I will throw a couple of those questions in there because that's important to know how to do. So 144 degrees in radians. Well, radians have pi. So we're going to multiply by pi, but we want to take out the degrees. And so pi is the same as 180 degrees. We're multiplying by what's called a unit fraction. It's a unit fraction in that pi radians and 180 degrees is the same distance. It's the same measure. It's just using a different unit. And so when you multiply here, the pi goes into the answer, and then we just start reduce the fraction 144 over 180. So that's going to be what? Actually, there's 4. Yeah, 4 divides both of them. This 3 divides. So 12 will divide both of them. 12 into 144 is 12, and 12 into 180. Is that 15? Yeah, that's 15. And then 3 divides out again, and so that's going to be 4/5. So that's 4/5 pi. 144 degrees is 4/5 pi radians. Yeah, if you have this worksheet, please go to the answer section and see if the answer to number 44 is 4/5 pi. Make sure I did it right. So like on number 12, it's a negative 480 degrees. Well, that's more than 360. So I take the 360 out, and that's gonna be a negative 120 degrees. And negative 120 degrees winds up in the third quadrant.
I'm sorry, they got 8 pi on number 44.
They got 8 pi.
Yes, sir.
For 144 degrees, they got 8 pi.
Here on the answer sheet, and it says that number 44 is 8 pi.
We're
Oh,
doing question 11 though.
Number 11.
He said the number. It's question 11. It was the right answer. It was 4/5 pi.
Yeah,
Okay.
4/5 pi. So, and negative 120 is the same as a positive 240, but they want it in the negative direction, so we're gonna have a negative 120 times pi over 180. Well, now we're gonna have a negative 120 over 180 pi and 12 over 18. 6 divides both of them, so that's going to be 2/3 pi, negative 2/3 pi. Yeah, because this is this is 4/3 pi if you're going the positive direction. But they wanted the negative, so. And 45 degrees, well, you know, you should know that from the unit circle that that's pi over 4. 5/2 pi, a negative 5/2 pi, which is the same as 3/2 pi. No. 1/2 pi. Yeah. I think. 5/2. 5/2. Well, yeah, because 5/2, you're gonna have to go around once and then another 1/2 pi. So negative 5 pi over 2 times, now we need to multiply by the reciprocal of the unit fraction that we had used earlier, because we want to take pi out of the number and put the degrees back in. Well, so we're going to put degrees back in, that's 180 degrees, and we're going to take the radians out by dividing by pi. 180 degrees and pi radians is the same unit of measure. It measures the same thing, they're equal. And so that's a unit, what we call a units fraction. The pi's go away, 2 times or 2 into 180 is 90. So that's going to be 5 times 90, which is 450 degrees. If I take out the 360, that leaves me a negative 90 degrees, which is what this is. But this is what they were asking for, the negative 450. And pi over 6 is 30 degrees, so a negative pi over 6 is a negative 30 degrees. 9 pi over 6, well, I would reduce that fraction first because it gives us smaller numbers to deal with. 9 over 6 reduces to 3 over 2, so that's 3/2 pi. But let me, it's the same number. So we're going to multiply this by 180 degrees divided by pi radians, the pi radians go away, and this is just 3 times 90 now, because 2 and 180 reduce to 90 and 1, and so that's 270 degrees. And was it positive? Yeah. So that was the same angle we were talking about here. All the trig functions for this angle are going to be the same as for this angle, because they all lined up here. Where this one went around once and wound up there. So those, you'll definitely have a couple of those on the test. One going from degrees to radians and radians to degrees. The sector measurements. As far as the scope of this class is concerned, I don't see them as all that important, but they are important for other things. That's why I included them. Knowing how to do this is an important skill to have in mathematics, but it's not imperative for pre-cal, I think. Well, that's me. If you're doing stuff in physics, then numbers 19 through 21 are helpful. But that's just knowing those formulas and understanding what they mean and what to do with them. And I've never had much use for it. But we put them in there because they do become important at some point. Yeah. If y'all have any questions for me? That includes you people.
Is the testing be the full class period?
Yeah. Oh, the test. Okay. Yeah. One second here. Let me do this. Okay. So the test will be online in Canvas. So on Zoom, you have only one option. You have to do it through Canvas. And in Canvas, it's not there yet. There will be a thing that pops up that says quizzes. And that's where the quiz will be. And there'll be directions. The first thing you do when you pop in there, there'll be directions for and it'll be, it says quizzes because that's what they call it. Yeah. So that's where the exams will be. There will be some answer places where if like on some of those where you do calculations or you find out things where you can type in your answer. Type in the answer you best you can, because you won't have the symbols for square root of 2/3. You won't have the symbols for square root and dividing by 3. Other than you could type in square root as SQRT 2 and put 2 inside parentheses and then divide by 3. Or you can write it out. the square root of 2 divided by 3, using the words. Either way, because what I do here, I look at your answers here and determine yes or no. And then if it's no, then this is the important part. You're supposed to upload all your work. Upload all your work, because you take your notes, you write all your fixed stuff down, and then you use if you have a smartphone, and most of y'all do, there's something called Adobe Scan. Some phones come with it. It's a free download if it does not have it. I know that iPhones, because people have told me before, has something that does the exact same thing Adobe Scan does. You scan in your documents. You scan them in one at a time and create a single file that's all the work. I had one person over the last couple of years that where most people scanned in 4 to 6 pages, he would scan in anywhere from 10 to 25 pages. Because every little work he did, even if he didn't cover the entire page, he would scan in, which is what I want to have happen. Yeah, that was a lot of work for me to find all the work he was talking about to get the answers, which is fine. Because that's just flipping through pages. That's not a whole lot of work. But I need to see as much work as possible to say, well, did you get the right answer here? And how did you get this answer? Okay. So if you got the incorrect answer, I want to know why. So I don't take away all 10 points. Okay, so I need to see some of the work. I need to see all of the work so I can help you keep as many points as possible. Because I'm about the process. If you're using the process correct, then the maximum number of points you could possibly lose is 4 points. This is very important. Otherwise, order of operations, or otherwise known as PIMDOS. If working out a problem and you have to use order of operations and you misuse order of operations, I don't care what the reason is, you misuse order of operations. In other words, you do not do it correctly. You lose 9 of 10 points. I quit grading. I circle it and put a -9 on the paper and move on. That's extremely important. Otherwise, chaos rules. And not in a good way. Okay, so order of operations is extremely important. I know of at least 2 or 3 other professors that I've discussed this with who agree with my assessment and they do something similar. They may not take off as many points as I do, but well, one of them just says the whole thing is wrong. But I give you 1 point for effort, even though this is extremely important. I talk about it too much because that's how important it is. Okay, so you work out each problem. You scan that in, and there will be a point. There will be something under the quiz for there'll be a submit button where you submit your work. And because of the nature of this class and the fact that people have other classes after this, they don't have enough time to scan it all in and put it in. I'll give you 6 hours to get that to me. So, well, 6 hours? by 5 o'clock, I think, by 5 o'clock that day is when you should have submitted the material. Do it as quickly as you can and as soon as you can, so you don't forget. And make sure you scan in every piece of work you did for that. So before the test, download that unit circle and print it up. So you don't have to take the time of drawing the damn thing and then writing in the angles and then saying this is 30 degrees pi over 4, and this is 45 degrees pi over 6, and this is pi over 4, and this is pi over 3, and this is pi over 2, and then you draw on these angles and put those all in. So printing up that really saves you time. What else?
Wait, so we print one that's already filled in or no?
No, you print up one, you print up the one that's blank.
Okay,
I showed you what it looks like. Okay, so you just print that up. And then that, and you can use that for the test because you're gonna have you're gonna need those degrees and those measurements for the test. What else? Yeah. So those of you through Zoom, this is the only option for you. For those of you in the classroom, you can come here, bring your laptop and do the test in here through Zoom. I mean, through Canvas in the classroom. You can go to the library and do it through one of their computers there. But first of all, before you even get in there, you have to get into Zoom. So I want everybody in Zoom. I want everybody on camera. If you are not on camera, I will fuss at you to get on camera. And I need to see as much of you as possible on camera. And I don't mean you get on camera and then point it towards the top of your head, so only your eyes are in there and everything behind you. No, I need to see your full face and possibly where you're working at, if possible. This is to help with the cheating aspect of things. I know it's not foolproof. I've had people cheat in the past, and I couldn't prove it, but there was evidence that there was cheating going on. So and so if I suspect there's cheating going on, I will note it in the test, and I will tell you how many points I'm taking off because I'm suspecting cheating, and it's up to you to prove me otherwise. Okay, so the burden of proof is on you to tell me that you're not cheating. Because all I can see is what I'm looking at in the little window I can see you there on, and what your work looks like. All right, if your work and someone else's work looks awfully similar, like last fall, there were 3 people. There were 4 people whose work was exactly the same. The mistakes were exactly the same. And in one instance, one person, you couldn't read one of their numbers quite right. So if you looked at it, it could be a 0, it could be a 6, or whatever. It was a 9 or a 4. So it all depends upon how you wrote the number. And so all the others wrote it down as the wrong number. So yeah, there's things that tell me, yeah, I see some cheating going on, but I can't prove it, but I can say, tell me why your answers here look almost exactly like this person's answers. All right. I know some of the work, yeah, well, all of the work, if you follow the procedure correctly, then everything or you follow the procedure the same way I do it, then yeah, all the work's gonna look the same, but there are some nuances that occur. I can see some things that show that, well, you're copying from them because you copied it exactly like they did, but your answer doesn't fit what you had written down. Because they knew what they wrote down, but what you wrote down didn't exactly fit what they wrote down. And so your answer didn't fit the numbers you had written down. That's happened. Anyway, I'm over time and I'm babbling now, so do not hesitate to email me with any issues you may have or any questions you may have. Well, Christine, bad internet, bad. Beat it with a stick. Okay. So, yeah. You too. I have to run and set up in a different room and hopefully not mess things up like I did this one.
Thank you, sir.
You're in here next.
Oh, I'm Amanda. I'm gonna help Mr. McWilliams, so I just thought I'd see what you
Oh,
were doing.
okay.
I'm
Oh,
killing
yeah.
time.
Harrison?
Yes,
Okay.
I'm just killing time. I thought I'd ask you if everything was going okay. I mean, you usually have a good backup plan. I know you. You usually have like 3 backup plans. You're ahead of us.
Well, I left my remote at home,
Oh,
so that's why I set that up.
oh,
I,
where'd you have that?
that's
Did you just
mine.
have it in your bag?
I have it in my bag.
See, I told you, you have your backups.
So, yeah, because,
That's wonderful.
and now my next 2 classes are totally remote, and I'm supposed to have a key to room 108, but the locksmith is dragging his butt, and I don't have a key to 108, so I have to run down to my office,
Okay,
set up myself for,
I wish I could help with that. I cannot.
because I have a 10 o'clock class.
Okay.